Kinetic envelopes are classified by dynamic elements on a building's facade. Energy-efficient kinetic envelopes use these dynamic elements to respond to real-time changes in the weather. Currently, 40% of the energy used in the United States can be attributed to residential and commercial buildings. Therefore, sustainable building design plays an important role in reducing carbon emissions. Static architecture fails to account for the unpredictability of our physical environment. With temperature and sea levels on the rise, it is clear that climate trends are rapidly and drastically altering. Therefore, energy-efficient envelopes must be responsive building skins that can capture, analyze, and respond to real-time weather data. Architects have been experimenting with energy-efficient kinetic envelopes since the 1970s. However, the case studies are far and few due to high upfront cost, lack of education about smart building technologies, and therefore low commercial demand. My research began by collecting data about buildings with energy-efficient kinetic envelopes and evaluating their performance based on a carefully developed criteria. The evaluation criteria is made up of three distinct categories: budget, parameters, and performance. Budget encompasses the initial and maintenance costs. Parameters include envelope material, the facade system, and the regional climate. And performance includes daylighting, ventilation, energy consumption, and occupant comfort. My findings categorized kinetic facade modules by their motion, scaling, rotation, translation, and material deformation. Though upfront costs can be high, they are justified by the long-term energy savings, especially considering 35% of a building's energy load can be attributed to heating, cooling, and ventilation. Finally, it was clear that buildings with the best energy performance incorporated multiple sustainable strategies in addition to kinetic facades. The goal of my research is to develop a kinetic facade module that can be affixed to existing buildings to help reduce energy consumption. A prefabricated modular product could help introduce dynamic elements into mainstream architecture.